Okay. All right, welcome to Math 341, Stat 341. I do apologize for those of you who are taking this as a stats class. I will occasionally be saying Math 341, just force of habit, because this is the first year the class is co-listed. Okay, it really should not matter one way or the other which way you are taking the class, the work is the same. And this does count towards both the math and the stats majors. So my name is Professor Miller. As some of you know, I love sending email. There will be a lot of email going back and forth about this class. What I want to do is, before I get into the lecture itself, I want to just start with one of my favorite game shows from my childhood. Anybody remember this game show? Yes. That's not, no, this is not Whammy. It's Press Your Luck, which eventually became Whammy. And so anybody know which episode this is? This is the most famous episode of the show. You've got a lot of extra credit already, yes.
Yeah, when he figures out how it works.
When he figures out how it works. So for years, they would not re-air this episode. Let me see. Yeah, unfortunately, with technology failures, we are not able to get the audio to play. What he's basically doing is, it goes around and you say, big bucks, big bucks, big bucks, stop. You have to sound excited. And if you stop on money, you get the money. Sometimes you get money in a spin. You get more spins. And you keep going until you get a whammy, at which point you lose all your money or you pass your spins on to someone else. This is from 1984. This gentleman is setting the record for the largest single-day winnings in American game show history to that date, over $100,000. At one point, they'll remark he had 31 consecutive times avoiding the whammy. So why am I mentioning this in a probability class? Yes?
Well, because the probability of 30 whatever times in a row of getting $4,000 plus a spin is very, very low.
Right, so no, the thing right now, he just hit 31, eventually, towards the end, they'll be marking about he's got, they'll show it with like over $100,000. So, what do you think? I mean, if we have enough people playing enough games over enough years, shouldn't we expect something like this to happen? How would you model whether or not this is reasonable?
Sort of like a normal distribution, and it seems like many standard deviation off of a normal expected.
Well, before getting to normal, I mean, how would we try to model this?
You find the probability of getting big bucks or whatever.
Sure. On each spin, what's the probability I don't hit the whammy versus the probability I do hit the whammy? They're complementary events. Their probabilities sum to 1. And then you see, how likely is it that somebody would get, say, 31 or more consecutive strings without a whammy? And then look at how many times people have played, how many days the game show has been on, and just see, do you think this is reasonable or not? What do you think? Reasonable or not reasonable? Do you think this is pure luck? Do you think this is the greatest press your luck whammy player in the history of the game? In some sense, yes. I'm sorry?
I said yeah, but not because he's lucky.
Not because he's lucky. Why?
Yeah, it just seems like you have to know something.
It's not random. He recorded the game on his VCR. This was, many, many decades ago. And he noticed that it was not a random sequence of paths when it went around the board. And so, I will put a clip up to the video, but you can actually see him smiling sometimes before his turn finishes, because he knows exactly which thing is coming next. So for him, it's not about luck at all. He knows exactly what's going to come up next. He knows the cycle it goes through. It's not randomly hitting all possible squares. It's going in a certain loop. And so he knows if I'm here, the next one is going to be here, which is never a whammy, always either big money or big money in a spin. And so for him, he has completely removed the randomness from the game. He got into a lot of trouble for that. And there was a debate as to whether or not CBS had to pay him. And then looking at the contract, for the game show, there's nothing that says you are not allowed to record the game show and look at it. Now, of course, what do you think Press Your Luck immediately does? Yeah, they fixed their damn random generator. There are a lot of opportunities to exploit situations where people do not have good random generators. The other one that I really love is there was a Canadian statistician who noticed that the Canadian scratch lottery was not entirely random, and you could actually predict with high accuracy which tickets would win. Being a good person, he decided to inform the Canadian Lottery about this, and they basically poo-pooed him. He then sent them 20 tickets and told them how to scratch, and he was right 19 out of 20 times, at which point they listened to him. And he knows that they were not doing a completely random algorithm, and that there was actually ways to look at the back, figure out what was going on. And so if it was me, I would have been training high school kids, in terms of how to scratch tickets. He was saying it wasn't worth his time. He was making more money doing his job than scratching tickets. But there are a lot of processes that seem random that are not random. So one of the big themes in this course is I want you to get a sense of when is something random, when is it not random? How can you use these to model things in the real world? This is going to involve computing and coding and whatnot. All right, by now I think everybody in the class should have toggled in. All right, so I want to just switch to just some of the general mechanics. All right, so as I was saying, the idea of probability is to model the real world. And in fact, in a few weeks, we're going to have some joint classes with another class taught by Professor Blackwood on mathematical modeling, where we'll be doing some of the same material. We'll be moving to a larger lecture room for that day. And we'll be seeing applications of some very elementary probability. The examples I'm probably going to be using is double plus one in Vegas and naval warfare, the Battle of Trafalgar. So these are two of the things that I really like, really nice applications of probability. So we want to learn how to predict the likelihood of events. I used to say the three most important classes you can take as an undergraduate are probability, statistics, and a programming course. And if you take these three, you will have a job. You may not enjoy your job, but you will have a job. For those of you who have taken a class with me, no, I can't say this anymore. Why can't I say this? And no, it's not because my Williams students aren't getting jobs. They're getting jobs. Why can't I say this?
There was like a lawsuit.
Yes, there was a lawsuit. So someone at Monroe College sued her school when she didn't get a job upon graduating. Now, it's great. I mean, because of the Freedom of Information Act, you can download her lawsuit where she misspells words like tuition and claims that her 2.6 is just as good as someone else's 3.6, and she's being discriminated against on the basis of her low GPA. So I cannot promise you a job, but if you have these skills, you will be highly marketable. I know we're not supposed to say that always at a liberal arts college. All right, so what are the objectives of the course? Obviously, I want you to learn probability, and I want to emphasize the techniques and the importance of asking the right questions. Frequently in life, this is the difficult part, asking the right questions. A lot of people get trained as technicians. They get trained how to do the computations. But figuring out which computations are worth doing, that's much harder. Along the lines, we're going to try to model problems and analyze the models. So depending on how sophisticated the model is, it may or may not be mathematically tractable. And so there's going to be a real pull between trying to capture all the key features in the system, as well as getting something that we can deal with mathematically at the end. Sometimes it's not going to be difficult to see what matters and what doesn't matter. Who's famous with Galileo's famous experiment? This is physics. What is Galileo famous for doing? Tower of Pisa. He has two spheres, he drops them, and the question is, does the mass of the sphere affect how fast it falls? How many of you have heard of this experiment? How many of you have heard what the colors were of the two spheres? All right, this has not survived to posterity. We do not know what color spheres he used. Why?
It wasn't important.
It wasn't important. Maybe there's a small chance it was really hot that day. One of the spheres was black, one of the spheres was white, one of them absorbs heat more, and then because it's hotter, as it's falling through the air, maybe the change in temperature, this leads us to Deflategate and whatnot. Maybe there will be some issues like this, but for the most part, I think the color of the sphere does not really matter in something like this. So it's what really matters. When I'm trying to model the problem of, does mass matter, the shape matters, the surface area matters. Maybe the height at which I drop it off matters, but hopefully the color doesn't matter. All right, so another thing is, how many of you are econ majors as well? Okay, one of the big problems in economics is that it is often hard to get a closed form analytic expression for your answer. It's wonderful if you have an answer that is a function of all your parameters, and as you change things, you can immediately see how your answer changes. So if you want to figure out what is the optimal rate for the taxes or for the Federal Reserve requirements or whatnot, it would be wonderful if you just had this beautiful math formula and you just plug these numbers in and you get the answer out. Typically, we can't do that. What we have to do is we have to do lots and lots of numerical simulations or experiments. And then we try to get some rough sense of what's going on. And then the more experiments we can do, maybe the more confidence we have about some of our results. A big part of this course is going to be programming. I don't care what system you program in. I'm very good in Mathematica, so I will be happy to help with that. The TAs, I believe, have some experience with R. I know for those of you who are taking stats classes, that's also a good one. I'm not going to have you doing serious programming. If you want to do that, by all means, that's fine. But you've got to be able to write some very basic code to investigate a couple of things. So for example, let's say I want to deal a hand of 5 cards from 52, and I want to know what is the probability you have at least 2 kings in your hand. There's certain implicit assumptions we make. What's an implicit assumption we're making when I describe this problem?
The deck's randomly shuffled.
Yeah, the deck is randomly shuffled. If it's a new deck, it is not going to be hard to calculate the probability I have, 2 or more kings. So we'll assume the cards are randomly shuffled, all cards are equally likely, there's no dependence between the cards. And so this is not a horrible calculation to do by brute force, but I want you to be able to write a simple computer code to do something like this so that you can check your work. Now, I don't really care about the probability of having at least 2 cards in 5. This is just a make-book problem to just keep you busy, but to learn useful skills so that when we get to things that are really important, you will be able to do them, and you'll be able to have a sense of, is your answer right and reasonable? So a lot of times, this is where people make or break their careers, is being able to just look at something and see, is this reasonable? One of my former probability students from Brown was in a big investment company, and right before they made a big move, things just didn't look right to him. And it turns out there was a minus sign error, and their strategy was very, very bad. But you want to be able to look at things and have a rough sense of what's going on. So for example, here's one of my favorite formulas. I know I've done this with my Calc 3 students a few years ago. It's called the log 5 method. So if I have 2 teams A and B, and A wins P% of their games and B wins Q% of their games, what's the probability that Team A beats Team B? And one of the 4 possibilities, I have 2 choices of sign up here, 2 choices of sign up here. One of the 4 is going to be right, P plus or minus PQ over P plus Q plus or minus 2PQ. One of these 4 does a really good job. If you haven't seen this problem before, a really nice exercise is to try to look at some extreme cases and try to get a sense of which do you think might do a good job. So if you haven't seen this before, what's a test you would expect a formula like this to pass if it's going to do a good job? So Team A wins P% of the games, Team B wins Q%. If you haven't seen this problem before, what's a test you think it should pass?
Extreme cases like 1 and 0.
Good. So if you have the team that always wins playing the team that always loses, then it's pretty clear the team that always wins should win. If you have 2 teams that always win playing each other or 2 teams that always lose playing each other, things are not so clear. Years ago, my brother and one of his friends were doing a old baseball program, and you could create your own players. So my brother created the perfect hitter who always got a home run every at bat. His friend created the perfect pitcher who always struck everybody out. And the 2 of them faced. And the computer hung for several minutes trying to figure out what the hell it should do in this situation. Any thoughts of the outcome of perfect hitter versus perfect pitcher? Double. Yeah, the computer compromised and said double. Perfect hitter always gets 4 bases. Perfect pitcher always gives up 0 bases. We'll give you a double. So whether or not this formula works in the case of 2 teams that are perfect, I don't know. You could look at maybe what happens if a perfect team plays a team that wins 99.9999% of its games and then try to look at the limit. But maybe there is a real change in behavior when you go to 2 perfect teams. So looking at 2 perfections might be troublesome. What's another extreme case we could try to look at to build some intuition?
If both of them win half the game, each team should win half.
Good, if both of them win half their games, they should win half. What if they both win the same % of games? So if I win 80% and I play somebody who wins 80%, what should my winning percentage be? 50%. So there's a lot of different things you can look at. So as a nice exercise, try to figure out which of the 4 is reasonable. Okay, so there's lots of different types of problems. If there is something that you want to see, shoot me an email and I'm happy to try to work this into the course. A couple of examples. We'll do a little bit on biology. Will certain species survive? Physics, chemistry, number theory, a lot of stuff in that area. This is my main area of research. Gambling, we'll talk a little bit more about that later today. We will talk about double plus one when we join forces with Professor Blackwood's class. Economics, the stock market and economy. Finance, Monte Carlo integration. For those of you who had me in Calc 3, you know that the biggest lie in Calc 2 is that integration is doable. Most integrals cannot be done in closed form. Most functions do not have nice antiderivatives. The way we actually calculate most integrals is essentially throwing dots at a board. And we see what fraction of the dots lie in the region. And that gives us a really good approximation for the area. And so these are called Monte Carlo techniques. There's a lot of probability in this. You want to know how likely is it that this estimate is close to the true value. And so this is the way a lot of integration is done in modern finance. Other examples is marketing. I've done a lot of work for movie theaters, movie distributors, cryptography. Any bridge players here? Okay. A lot of card games trying to figure out what is the right strategy to do in various settings. Okay, so I've had a couple of applied experiences over the years. So as I mentioned, I've worked for movie theaters trying to figure out what is the optimal way to show movies. This is trying to do what? What is our goal if we're a movie theater? Make money, good. Right? It's not to show movies. That's not our goal. How do we make monies as a movie theater? So you're a movie theater. How do you make money if you own a movie theater? Ticket sales. What else? Popcorn concession stands, right? Which do you think you make more money from? Concessions. Especially if you look at how the contracts are negotiated with the people who own the movies. The first few weeks when the movie is out, you actually pay more of each ticket sale to the owner of the movie. As the movie's out longer and longer, you get to keep more and more of the ticket sales, but fewer people go. There are some times when movie theaters have movies showing for almost nothing because they're just trying to fill up screens and get people to buy the junk food. So in terms of trying to figure out what you want to maximize, it's a very interesting question. You want to try to figure out what do you think the demand is going to be. So there's a lot of really good statistics and probability in something like this. The reason I'm wearing this shirt is some of the work I do is on Benford's law of digit bias. I was actually contacted by the IRS a couple of years ago. The first time they contacted me, I was I think I was either just starting my postdoc or just finishing up graduate school. And the email began, greetings, my name is David Kelly. I'm a senior criminal investigator at the Internal Revenue Service. And when you get an email like this, you stop reading for a while. And so my office mates, I don't want to talk about it. And it took me a while before, I read the rest of the email, which was, I just read with interest your recent paper in Acta Arithmetica. And I was such a young researcher, the fact that anybody would read one of my papers was still quite surprising. And so the distribution of leading digits is not what you would expect. So if I ask people, I'm supposed to do this, I'm not a good professor, so I won't. I split the class in half. Half of you flip a fair coin 100 times. Half of you simulate flipping a fair coin 100 times. You show me the results, and I'm supposed to impress you by telling whether or not you made it up or actually flipped the coin. What's the first thing you think I look for to tell, did you make it up or was it real? First test you think I do. Supposed to flip a fair coin 100 times. What do you think I look for?
Long sequences.
Nope. Second thing I look for. So that's advanced. What's the first thing I look for? Totals. How many heads, how many tails? I want to see about 50-50. You unfortunately blew it for me because most people don't think to look for long sequences, but excellent observation. Most people do not know how long of a run of heads you should see. What should be the longest run of heads or the longest run of tails? This is a great way to tell if somebody has made up data. For a distribution of numbers, it turns out that there's a bias in the distribution of numbers, and we'll talk about that later this semester. The last, and I'll talk a little bit about this more later, is I've done a lot of work in sabermetrics, the art of applying math and statistics to the sports community. In terms of the amount of math and statistics you have to use, this is very minimal compared to a lot of the other math I do. In terms of financial impact, this is much greater than most of the math I do. Okay, so just some course mechanics. So we are going to be moving at a fast pace after today. All right? You are responsible for reading before class. And I will be talking much more about this. This will be 5% of your grade. I will assume that you will come to class prepared. This is your job. Okay? Homework is 15%, writing is 10%. That's going to be writing some problems for the book, checking some things for the book. It's going to be maybe reading a probability paper and writing a summary on it. I want you to do a little bit of technical writing. The midterms will be probably 2, and I will drop the lowest one. The final exam will be due at the end of the semester. If you want to hand it in later, we can talk about that. Hopefully I'm out of the range, okay? So that will be 40%. You are also welcome to do a project, either by yourself or in a small group, which can count for up to 10% of your grade, and I will adjust everything accordingly. So if you want to explore something in greater detail, I'm happy to encourage you to do this. It's a chance for you to control your education. There are a lot of topics, far more than we will be able to do in the semester. I'm also happy to have a lunch once a week where we either talk about sabermetrics, mathematics applied to sports, or just probability in general. If people are interested, let me know. Prereqs for the class, Calc 3, basic combinatorics, set theory, and linear algebra. Okay, I'm not going to be able to spend much time on stuff like this. If you have any problems with any of this, I will present additional material online, and by all means talk to me, talk to the TAs. But unfortunately, we don't have enough time to go through and review all the material. I have set aside essentially an hour every day, Monday, Wednesday, Friday, 8:40 to 9:30, Tuesday 1 to 2, Thursday 2:30 to 3:30. Homeworks will be due on Friday, starting next week, not this week. There will be TA sessions on Sundays, Tuesdays, and Thursdays. The first one I just found out will be this Sunday. They will be in Bronfman B34. That's the sub-basement 2 levels down. We've deliberately chosen that so that there will be no distractions to prevent you from concentrating. You won't see beautiful snow or nice spring scenes or anything like that. You will see nothing. There are no windows that low in the building. Feedback. You may email me anonymously if you do not feel comfortable emailing me directly about either issues in this class or anything at all. The email address is eefsmath@gmail.com. The password used to be the first 8 Fibonacci numbers until somebody reset it. And so fortunately I was able to talk to Gmail and get the account back and change it. It's now Williams1793. The only thing I ask is please do not reset the password. Okay? But again, if you have any concerns about this class or anything in general, this is just a way for you to provide some anonymous feedback without my knowing who it's coming from. And then I can either respond to that account or I can just respond in other ways as appropriate. Okay, so there will be a course webpage. I don't use Glow or Glow 2 or whatever they're shifting to right now. I use very old primitive HTML code. But what's nice is I can just migrate stuff very easily from my classes. And whenever I get these emails saying Williams is now changing to this system, I can just hit delete. So I will have numerous handouts, additional comments after each lecture, a mix of additional advanced material. All that stuff will be available there. In other days, we will try to use clickers. I might adjust things a little bit today since the clicker count is not working. I will be emailing the textbook later today. I wanted to just wait to see who was in the class. There were some things that were changing, so I will email that later today. I also wanted to not let people read ahead so that I could do some clicker problems and get your feedback without having read the book and get honest evaluations, but oh well. All right. And then just because I will be mentioning this multiple times and it's in red, that seems like it's worth mentioning again, prepare for class. All right. You are responsible for having read the relevant section before we meet for class. All right. So one of the reasons I'm so big on this is you never know when opportunities are going to present themselves. You've got to be prepared for whatever happens. So this is myself at the 61st birthday conference of one of my thesis advisors. This was at the Institute for Advanced Studies in Princeton. There was a banquet. There were over 200 of the strongest mathematicians in the world. There were Fields medalists there. And I found out, not surprisingly, that there were a couple of people who had been asked to say a few words about Peter Sarnak at this event. I was not one of the people asked to say anything about him. But as soon as I knew people were going to be speaking, I quickly prepared a speech just in case. Because if all of a sudden they hand me a microphone, I don't want to sound like an idiot in front of some of the strongest mathematicians in the world. And it turns out I was actually one of the people who was just handed a microphone that night. And so I had a couple things already prepared. I had quickly memorized a few bullet points, and I was fine. But you do not know when an opportunity is going to present itself. I have 2 little kids at home. There's a link to them on the homepage. They are 5 and 7. I have plenty of dealings with little kids. I do not want to have that here. I want to have the adult conversations. I want to have the in-depth discussions of things. I do not want to treat you like I treat my 5 and 7-year-old. I don't want to give you pop quizzes and stuff like that to check and make sure you are doing your reading. That's your job. Your job is to be prepared for this class. Okay? If any of you want to be treated like little kids, as long as you're willing to shovel my driveway, that's absolutely fine, let me know. There is one way I will treat you by my kids if you want, and this is a class vote. Some of my students protested a few years ago because they found out Cameron and Kayla get M&Ms when they solve math problems correctly. And so if you want, I will bend my rules to that extent, and I will bring candy to class for people who participate. So unless I hear objections, I will start on Monday by bringing down candy. Okay? All right. So again, last time I'm going to say this, be prepared for class. I cannot cover all the material in class. I cannot go through. There's just no way to do this with the amount of time we have and the amount of material we want to get through. So I will give you bullet points of what to look at so that when you read the following section, you should be able to answer these questions. You should have been able to define this concept. This does not mean if the elementary school closes, and they've closed twice this week, which is wonderful the week before classes start, that you can then do the lecture. But you should have an idea what the lecture is going to be on. You know, if the lecture is on the central limit theorem, you should know what the central limit theorem states. You should know what the variables are. You should know what the key definitions are. You need to be at that level before class. Come to me whenever. If I'm in my office, it's office hours. You know, ideally, I would like you to try to come during the hours I've blocked off because it's more effective if we have a lot of people there. Somebody might ask a question that's also good for you on something that you might not have thought of. So I would love to do that if possible. But if I'm in my office, it's office hours. Feel free to shoot me an email anytime. I am usually very good at responding to emails within 3 hours between 9 p.m. and 7 a.m. And so if you are stuck on something, shoot me an email. I will try to respond. Okay. And then just some advice from my brother. The first is party less than the person next to you. So for those of you who are sitting on the edges, you know, you don't have quite as much opportunities as people who are in the middle. His second piece of advice is take advantage of office hours and mentoring. He's in the real world. And you know, one of the great advantages of Williams is how accessible people are here. You are not going to have that in other places. So take advantage. Talk to me, talk to each other, talk to the TAs. This is why we're here. I won't say where because this is being recorded. There is an institution that I taught at where somebody had office hours 8:30 a.m. the day after homework was due. And it was quite clear that the person did not want to talk to the students, and the students got the message. There was another institution where the professor prepared the wrong class. You know, this is not Williams. You know, the reason we are here and the reason you are here is to talk to each other. So please come to my office, shoot me emails, talk to each other, talk to the TAs. And his last piece of advice, which is a great one, is learn to manage your time. No one else wants to. Get things done. As soon as something comes in to your inbox, try to get into the outbox. Work on some of the problems each day. You know, there's going to be a lot of homework problems due. Don't wait until the last minute. Space them out. Try to do them as soon as possible. The first week is going to be very rushed with all the reading you need to do and all the problems you need to do. I want you to see from day one what this class is going to be like. I try to have my classes more intense in the beginning and less intense as the semester progresses because I know some other classes, especially reading classes, realize that they're a little bit behind in the reading towards the end of the semester and the reading workload increases. So I want to be able to spend a little bit more time just slowly going over material towards the end. All right. The other thing is I know there are some seniors in the class or people who are going to have to travel for various things. If something is coming up, you know, sport event, job interview, whatnot, I am very happy to adjust deadlines. I'm happy to give you practice interviews with myself if you want to just prepare you for various things. You know, anything I can do to help you, just let me know. Okay. Any general questions about the course before we start getting into some of the material? All right. All right, so it's getting a little warm in here. So in 2007, a friend of one of my favorite students made a bet, $500 at 1,000 to 1 odds that the Patriots would go undefeated and win the Super Bowl. Any football fans here? Okay, what is the probability he wins this bet? So this is one of the problems with the technology, is technology frequently fails. I'm getting very frustrated with this technology. But there's two ways of looking at this. So one is, when Vegas sets a line, what they're trying to do is they're trying to set it up so that they have equal amounts of money bet on both sides. So these batteries were just charged before coming in here. Is it still recording? It's still recording. I apologize about this. Well, no, but the problem is if this is not on, it doesn't record my sound. It's set up so that it's not supposed to get too well sounds from students in class, so that you can speak up without fear of it being recorded. I don't have that option. All right, so as long as now, I'll try one more time. So one of the reasons I like to do this is so that if somebody misses class or if you want to review something, it's all there. But the technology is just, I'm going to have to talk to OIT again. All right, so I will try to move this closer to myself so that it can at least record me. And hopefully it's close enough that it will pick it up. All right. So one potential problem, is Vegas needs to make money. And so because Vegas needs to make money, you're not going to get perfect odds. But there is another thing you need to take into account when lines are set. Vegas is not putting down what they think the outcome of the game will be. They are trying to maximize their profit or minimize their losses. They want to have the money split equally between the two sides. Because if it's split equally between the two sides, it's not gambling for Vegas. So when they set a point spread, they don't really think that that's going to be the outcome of the game. They think that this is what they need so that half the people will bet one way, half the people will bet the other way. They take Peter's money and give it to Paul. So you've got to be very careful when you're looking at point spreads. Now, of course, right now, what is the probability that this person will win this bet? I'm sorry? Zero, right? The probability is zero. This happened, right? This happened many years ago. I Googled best Super Bowl catch a while ago, and this is one of the things that turned up. The incredible helmet catch by Tyree a couple of years ago. Right? So for something that's already happened, it's not that hard to calculate what is the probability of the event. The difficulty is events that haven't happened yet. So now, my student told me about his friend who made this bet. In the third quarter, with the Patriots up, Vegas calls him. He's got $500 on the Patriots to go undefeated and win the Super Bowl. And Vegas offers him 300-to-1 odds to buy back the bet. So Vegas will give him $150,000 right now to limit their exposure. All he has to do is stop the bet. My friend's friend says no. What was his mistake? No, the mistake is not this. What was his mistake? What did he do wrong?
He maximized his expected odds.
So one thing is he's trying to maximize his... Okay, so we got to phrase it very carefully.
He's trying to maximize his returns.
He's trying to get the biggest possible return. And so if he takes Vegas's offer, he's going to cut down on his possible return. Right? But what could he have done if he's not trying to maximize his possible return? What might he want to do instead?
Just
Yes.
Could he sell back part of the bet, but not the whole?
So one possibility is to explore, could he sell back part of his bet? Vegas might say, no, it's all or nothing.
Could just hedge before they do it.
Yes! He was a moron. He should have hedged. So let's assume the Patriots win with probability P, the Giants win with probability Q, which is 1 minus P. So if you bet $1 on the Giants, let's assume you get X dollars back. Okay? Depending on how you do things, it's a question of, do you get your initial money back, or is it your money that you bet is gone and then you just get X dollars back? With the $500 bet, it doesn't really matter. We're talking about 500,000 that overwhelms the 500. For the smaller thing of putting an additional bet on the Giants, this is going to matter enormously. So we can calculate what is his expected winnings. So if the Patriots win P% of the time, they lose 1 minus P of the time. And so we look, well, P% of the time is going to get 500,000. And let's say he bets B on the Giants, and let's say the Giants will win with probability 1 minus P. And for every dollar you bet on the Giants, you get X dollars back. This is how much he gets if the Giants win. And then this is the bet he made on the Patriots, which he always loses that money, and then he always loses the money he puts on the Giants. Are you surprised that the more money he bets on the Giants, the lower his expected winnings are? Is this surprising? What do you think? You want to get to the point where you can look at mathematics and see, is this reasonable, yes or no? What do you think? Surprising or not surprising?
What P is that, this is?
P is 0.8.
Because the payout's so high.
So the Patriots have an 80% chance of winning. So you have a 20% chance of winning, and I didn't tell you what X is. You can probably figure it out from here. X is 3. So 0.2 times 3 is 0.6. So your expected value is very bad in this situation. So the more money you bet on the Giants, not surprisingly, the lower your expected value is. So if you are trying to solve real-world problems, one of the big things you have to ask is, what is the right question? Am I trying to maximize my return? That could be extremely risky. What if I want to decrease risk a little bit? A much better thing to look at is by hedging. And so imagine we put down B dollars on the Giants. Here I'm doing X is 3, so every dollar you bet on the Giants, you win $3. And I'm going to say the Patriots have an 80% chance of winning the game. I will forget about the outcome. I will say most of the time that catch is not made. And if I look now and see, how much money do I get? What do you notice? So I'm looking at the minimum of 2 possibilities. Because right now, either the Patriots win or they lose. If I bet nothing on the Giants, what's the worst possible case for me? Giants win. Okay? If the Giants win and I have no money on the Giants, that's bad, and I'll make 0. If I bet a little bit of money on the Giants, then if I bet a little bit on the Giants, and even if the Giants win, I'll get something. If the Patriots win, I get a lot more. So in this row, for small values of bets on the Giants, it's not surprising that I'm going to be making a small amount of money. But this is guaranteed now, because I have money on both the Giants and the Patriots. And as I keep betting more and more on the Giants, I'm going to increase the minimum amount of money that I will win. What's going to happen to the maximum amount that I'm going to win? It's going to go down. I mean, here, if the Patriots win, I make $500,000. Over here now, if the Giants win or the Patriots win, there's a certain bet where I'm going to be indifferent between the two. And so it's not going to really matter for me if the Patriots win or if the Giants win. But notice I'm only going to be making about $325. Why am I making so much less than I did before? Why am I making so much less? Yes?
Are you betting like 100%?
Yeah, I'm now betting over almost $200,000 on the Giants. I'm a big Patriots fan, and when the Patriots were given 14 points over the Giants in 2007, 2008, I'm not a betting man, but oh God, I wanted to put money on the Giants. Put down $200,000 on the Giants. If the Giants win, great. You've now covered yourself. If the Patriots win, you only have $350,000, $325,000. This was the mistake my friend's friend made, is he had a chance to minimize risk. This is a very simple probability calculation, yes.
I feel like one of the issues is you might have to go to a few different casinos.
So-
I don't think it's gonna let you place them.
You might have trouble placing $100,000, but you might have to absolutely spread it among several different people. How many of you have read or seen the movie 21, Bringing Down the House? There's some very good stories about how certain bets are made and how certain things are spread out. But you're absolutely right that sometimes you will not be able to have someone take the bet. But if he had done a simple calculation like this before the Super Bowl, he would be 300,000 plus richer, with no risk. And so you have to ask yourself, he's costing himself maybe $175,000. What is the marginal utility of getting $500,000 versus getting $325,000? And sorry, I'm saying marginal utility. That extra $175,000 you get, which is now very risky, versus a guaranteed $325,000. So to me, that was the big mistake. So here is some very simple mathematical code to do problems like this. And so I will have a mathematical video and tutorial online that walks going through stuff like this. So the functions are very simple. So f, this is going to be a function. You put things in square brackets. You do an underscore to mean variables. So this function is going to be a function of the variables p, the probability the Patriots win, x, the payoff on the Giants, and b, the amount of money we bet. This is our expected value. The function g, which is related to this, is going to be the guaranteed winnings. You do no worse than this. Now, of course, you can do much better than this if the right way goes. So, over here, in this realm, I would much rather have the Patriots win because I have very little money on the Giants. Over here, I would much rather have the Giants win because I have a lot of money on the Giants. And so, these are very simple functions to write down and get a sense. If you want to then plot things, very simple commands plot. I'm going to plot b goes from 0 to 500,000. There's a really nice feature in Mathematica called manipulate. And so what manipulate does is it takes this command over here, this plot command, and then it allows me to change the values of some of the parameters. So here I'm going to have p go from 0 to 1, I'm going to have x go from 1 to 10. And you end up getting a little box like this with some sliding bars. And you can adjust these and put in different values. So I set the probability p of the Patriots winning to about 51.8% in honor of some of the Giants fans in class to make it an almost even game. The Giants played the Patriots very well at the final game of the regular season. I thought it was ridiculous for the Giants to be 14-point underdogs. Let's give the Patriots a very small probability of winning. And then what you can do now is you can vary these numbers and you can see how things change. How do you think this will change if I change the payoff on the Giants? What do you think will happen?
There's a higher payoff on the Giants. You should have more money on the Giants. So at that point, we'll move to the right.
Good. So without even doing any of the calculations, you have a wonderful intuition. This point should move to the left.
No, it should move to the right.
It should move to the right.
You should have more money on the Giants.
Okay, so now the question is, where do we think that critical turning point will be? Where I become, indifferent between the Patriots and the Giants winning. I think the point moves to the
left because you don't have to put as much on the Giants.
right. Go to ridiculous extremes. Go to ridiculous extremes. Imagine for every dollar you bet on the Giants, if the Giants win, you get $20 billion. All right, I'll put a penny down on the Giants. So, without even doing the calculation, as x increases, I expect this point to move to the left. What do I expect about the magnitude of my winnings to do? Do I expect it to stay at the same height? Do I expect it to get higher or smaller?
When it moved down as x decreases.
Okay, so let's do x increasing. So if x gets larger, what do I expect to happen to my winnings? Do I expect them to be going up or going down? Up. Because as x goes up, for every dollar I bet on the Giants, if they win, I make more money. So it seems to me very likely that at least in some of the region, when I'm betting on the Giants, I should be getting more money. What about as I change the probability p? How do you think that should affect things? As I change the probability that the Patriots win, how should that affect this graph? What do you think?
P wasn't a factor in that.
P is not a factor. I'm looking at my guaranteed winnings. So at each moment in time, I'm asking, what's the worst possible thing that could happen to me? And going back a few possible pages, as a Patriots fan, this is essentially close to the worst. Okay? P is not a factor in any of the mathematics. When you look at the formula for G, for the minimum, P does not occur in it at all. And so in terms of getting the sense of what goes on, it doesn't matter what P is. If I want to look at what is my expected winnings, P matters. P has a huge role in expected winnings. You can see it playing the role over here. I want the largest possible P if I've got small bets because I'm getting that $500,000. But in terms of what's going on over here, P is immaterial.
All this that you're talking about is doing like a money line bet, right? Just because of the spread, there's a big range where you could have bet against the spread in one.
Yes, I'm right. There's lots of different bets you can make. The point I just want to get here is this is what I want you to get out of the course. I want you to get out of how to look at a problem, how to look at related problems, how to think about stuff like this. I will end, though, with what I think is now considered the greatest Super Bowl catch of all time. Because unlike the Giants one, the Giants still had to do a lot of things right after that play. Whereas this almost ended the game. There was still the possibility of a safety. Alright, so I hope this gives you a little bit of a flavor of what is going on with the class. There are some technical issues that I'm going to have to work with OIT again on about this. And then I will shoot you an email. I might adjust things a little bit because the clickers were not working today. Alright.